twice the first subtracted from the sum of the other three integers is 16. Did you do any problems like this in class to get an idea of how to even start something like this?
We didn't.
Okay. So the hint here is that you let x be the first integer.
All right.
So let's just say x is 3. We know that it would be 3, 4, 5, and 6, right? To
Yeah.
get the next one though, it's x plus 1. That's the second. X plus 2 is the third, and x plus 3 is the fourth. So rather than using different letters, you want to increment the first variable.
All right.
Is that okay?
Yep.
All right. So now we gotta like parse this sentence. Twice twice the first. So twice the first is 2x.
Mm-hmm.
Subtracted from the sum. So we're gonna subtract this from the sum of the other three. So the other three are x plus 1, x plus 2, x plus 3, and then we're subtracting this 2x. This ends up equaling 16. Just clean this up here a little bit. So the sum of the other three integers, meaning the second, third, and fourth, 1, 2 plus 3, subtract twice the first, you get 16.
How do you know if it's x plus one, x plus two, or an x plus three, or if it's something different?
So because they're consecutive integers, they're going up by 1. You'll
Okay.
see problems where it's even, and then it would be x plus 2, x plus 4. Odd would also be x plus 2, x plus 4, and so on.
All right.
Good question. I mean, we'll see it maybe the next one here. So now we just have to solve this equation. So you drop the parentheses. And you combine like terms. So you've got 1x plus 1x plus 1x minus 2x. That ends up being just x. And then you've got 1 plus 2 plus 3 is 6. And then you solve this by subtracting 6 from both sides. So x equals 10. Okay, is that okay?
Uh, is x plus x 3x?
Yes.
Okay.
Yes.
All
And that's
right.
where I get the 1x because you subtract the 2x from there.
Yeah. All right. Thank you.
All right. So this is not the answer though, because the question wants 4 consecutive integers. The first integer is 10. Use red. That's 10. But now we need to find the second one. Well, it's 11, 12, and then 13. So sometimes they want you to write a sentence or like say like you have to say the 4 consecutive integers are 10, 11, 12, and 13.
Yeah.
And then if you want, you could try to um you could try to verify that this works, like double the first, which is 20, and if you add these three up, you end up getting 36. 36 minus 20 is the 16, and you know that it works.
All right.
If there's no further questions, we can go to number 10.
All right. Sounds good.
All right, let's do it. These aren't very exciting, but they are what we have to get through tonight. All right,
Yeah.
the length of a rectangular playing field is 5 meters less than twice its width. So I believe you said you played sports. Um,
Uh-huh.
so you can choose which one you want to be the length and the width. It doesn't really matter. Um, so let's just call this W. I'm going to call that W. So it says the length of a rectangle playing field is, that means L equals. L equals. Whenever you see that variable and the word is, you get it's L equals 5 meters less than twice the width. So for whatever reason in the English language, you double the width first and then subtract 5. Even though it says 5 meters less, we know that that means subtract 5 is the way the English language works.
All right.
So the other dimension is 2w minus 5. The one across here is w. This is 2w minus 5, like that.
All right.
And so now we know that the perimeter is 230 meters. 230 meters of fencing goes around the field. So we have to add these up. The perimeter is w plus 2w minus 5 plus w plus 2w minus 5. We're basically just making a path going all the way around, running a lap, if you will. But we know that the perimeter is 230. So if we combine like terms here on the right, we got 1w plus 2w plus 1w plus 2w, that's 6w minus 10. Any questions on up to this point?
Nope.
All right. So could you attempt to solve this for us, please, this two-step equation?
Sure. Is it W equals 40?
W equals 40, but that's only part of the answer because you have to give both dimensions. Dimensions means both the length and the width. So you might say the width is 40. The length is 2w minus 5, which is 2 times 40 minus 5, or 70, 75. Sometimes it's good to throw in units. Let's see if yeah, meters. So, meters and meters in this case.
All right.
Is that okay?
Yep.
All right. These are all word problems, aren't they?
Most of them are. A few of them are.
Fantastic. Fantastic here. All right. Number 11. A car rental company charges $19.95 per day for a compact car. That's a fantasy. It's like triple that now. Plus 12 cents per mile for every mile over 100 miles driven. If Mr. Wu's bill for 2 days use is $46.86, find how many miles he drove. Okay. All right. So what they're saying here is like the first 100 miles are basically free, but then you get 12 cents for every mile over that. It is kind of like it used to be with cell phones. They gave you a certain number of minutes free or text free, and then you got charged over that. It's not
Yeah.
real representative of today. I mean, we buy subscriptions. It's a one-time thing, but
Mm,
that is not the case here. So the cost as a function of miles here is 19.95 per day. Okay, so actually we need to add in another variable here. So let me do this differently.
all right.
It's 1995 times the number of days plus 12 cents for every mile driven over 100. Okay, so if it's less than 100, we basically ignore this part.
All
But
right.
since we're pretty sure he drove over 100 miles, we're gonna carry this out this way. So this is his cost. Um, this is a piecewise graph, by the way. Have you guys been working on that in class?
No, we haven't.
Okay. This is a little odd that they're giving this to you. Okay. The cost is 46.86. We know that he goes 2 days because it tells us that. And we're trying to figure out how many miles over 100 that he is going to, and he has driven. All right. So
Yeah.
2 times 19.95 is $39.90. And you subtract 39.90. What do you go? So if you got a calculator handy, if you could help out here with some of these calculations. This is my last lesson of the day, I believe. So I do get tired. Let's just double check these, make sure they get right. I got 6.96 here equals 0.12, like that.
All right, then I'll just check it. All right, I got the same thing.
Excellent. Now, rather than multiplying this 0.12 in, we're going to divide by 0.12 on both sides. And you should get 58 equals m minus 100. Adding 100 to both sides, you get m equals 158 miles. These problems often work out nicely. So if you get an answer that isn't nice, probably made a mistake. Just consider that when you're working through it.
All right.
All right. Any questions before we move on to number 12?
Yeah. Sorry.
I know sometimes I go too fast. If you need me to scroll up, I'm happy to do that as well.
No, it's all right. I was just finishing writing.
All right. I need to just step away for 10 seconds to adjust the thermostat. I'll be right back with you and we'll work on this question.
All right.
All right. The cost C of producing X number of scientific calculators is given by this function. C equals 4.5x plus 3,000. The revenue R from selling them is given by R equals 16.5x. Find the number of calculators must be sold to break even. Very important thing in economics, business. So break even in this case is when revenue equals cost. R equals C. R is 16.5x. C is 4.5x plus 3,000.
Wait, I don't think I understand. Like, why is CR?
That's what they're saying here at the end. Break even. So let's just say you and I wanted to start a clothing company and we're going to sell I don't know, shorts.
All right.
Okay. We're going to sell shorts for $16.50 each. So every time we sell a short, we get $16.50. But we have a cost. It costs us $4.50, and there's the startup cost of 3,000. What we're trying to figure out is like how many shirts do we need to sell or shorts so that we don't lose money.
Okay.
And so this is like a pure business thing to think about. If you're not in business or don't care about business or you haven't done anything, like you said, it won't make a ton of sense. But um, the let's just keep it really simple. Let's just work through how to solve this.
Okay.
So you got variables on both sides. Which way do you move?
To the left.
Yeah, you subtract 4.5x. 12x equals 3,000. Divide both sides by 12. What does x equal?
All right, just give me one side. 250.
So that means we have to sell 250 calculators to
All right,
break even. Give me just a moment, please. Be right back with you.
no problem.
Okay, so this is the final answer here to this. We can get more into this maybe at a later time. Uh, Now, should we go to the word problems or go to like jump to 16, 17, 18, which are not word problems?
Why don't we just do 16, 17, 18?
All right, let's do it.
I actually
So
I tried to do 18 earlier. Can I like just check my answer real quick? Just see if it's right or not?
sure. Yeah, what'd you get for number 18?
Uh, I got G is equal to S minus BT divided by T squared.
That is correct.
Oh, yay.
Good, good, good. All right. Yes, let's do 16. It's always good if you make an attempt. We actually learn more from, what's called failures, really not failures, just results, but we learn more from making an attempt at this. So
Yeah,
Um, we're solving for X. One of the most common things that we have problems here with in these, like you got to make sure you know what variable you're solving for. It's like sometimes you point it out or maybe you highlight it, but you really want to make sure that you know exactly what you're solving for.
all right.
Okay. So in this case, we're going for the X. So we first undo this M here by dividing it on both sides. Y minus Y1 over M equals X minus X1, like that.
All right.
So the tendency is to multiply in, but that makes it more complicated. You can divide it out this way. Now, to get to X, we're still trying to get to X, you have to undo the subtraction. You do that with addition, you add it to both sides. Let me just create a little space here so we can see that. We're gonna add it here. You can't add it to anything. It just kind of lingers off to the side. Y minus Y1 over M plus X1 equals X, like that.
All right. How do you know whether to add like if X1 like to the top or to the bottom?
You are not able to, you're not combining it. It's just off to the side.
Okay, but you have to put it like in the bottom under the line and not like with the Y, right?
Uh, like this is how you want to, you don't, I mean, I almost want to, I don't like giving you wrong answers. Like if here's what I think you're asking. Maybe you can, is this what you're asking?
Yeah.
No, this is completely, we don't ever want to do that. You cannot combine these. It's just off to the side here. The reason
Oh,
is
so
because it,
completely off to the side?
yes.
Oh, okay.
And
So
I,
you
and I know you don't like that. It's ugly. It doesn't look right, but there's nothing to combine it with.
all right. So if you can't combine with anything, it's like off to the side completely and not like with anything under the division bracket.
Exactly. Yeah,
All
exactly.
right. All right.
So I know this looks weird, but that is the final answer.
All right.
All right, so 17 here. This one has kind of a non-obvious thing to do. So do you see that there's a G in both positions here?
Yeah.
So you have to actually factor out a G.
What does that mean?
It's they call it in class they call it a divide and slide thing. If you divide both of these by G, what is left over? See how the G's cancel? What is left over?
Oh, okay. So it just like cancels. Okay.
Yeah, so it ends up being R plus VT. They call it a divide and slide.
All right. Why didn't I
So
have to divide the T by G?
so this you are, but the these are all I have to you almost need a numerical example here, so let's do that. Let's
Okay.
say it's 4, 2 times 3 times 4, and we divide it by 2. Okay.
Mm-hmm.
So if we cancel these, the answer is 3 times 4, which is 12. Is that okay?
Yeah.
Now let's do it differently. Let's divide the 4 by 2. What does that become?
Two.
2. And then 2 times 3 times 2 is 12. But
Oh,
what you cannot do is what I think you're kind of implying here, and this is a good question, is you don't cancel both because then it becomes 3 times 2, which is 6, and that is not correct.
all right. Okay.
All right, so now we've got P equals G times parentheses R plus VT, and we're trying to get to G. Our goal is to solve for G. G is being held up by this R plus VT in parentheses. So I know this is awkward, but you divide everything by R plus VT. You divide by everything inside parentheses
All
because
right.
that is what cancels.
Got it.
So again, it doesn't mean anything, but it's T divided by R plus VT is your final answer.
All right.
These are called literal equations, 16 through 18.
Yeah.
We definitely need some more practice on these if there's time. Um, but that is up to you. I see 19 as being next. Does that look right to you?
Yeah.
Right. So we kind of started doing problems like this, I think in one of the either our first lesson where there's a formula for interest that you have to know. And I'll put it up on the screen here again. The future amount is the starting amount, 1 plus the interest rate divided by the number of compounding periods, times the number of compounding periods times t as an exponent up there. So you have to know this formula, but more importantly, you need to know what each of the letters are. P is the principal. This is your rate, but it has to be a decimal.
All right.
This is the number of years, T. And then they're giving you A and B as two different ends. So semi-annually is 2, weekly is 52. 52 weeks in a year. To semi-annually is twice a year. So the calculation for part A, you're just putting these numbers into the equation. So it's 3,000 times 1 plus the interest rate R is 0.03. You take the 3% and divide it by 100. The number of compounding periods for part A is 2, and that's 2 times 7 power, like that. So we
All
talked
right.
about getting the hardest part is probably getting this into the calculator. I think we resolved any issues at some point.
Yeah.
Um, but go ahead and give this a try, please. See if you can calculate this for me, please.
All right. Do you multiply by 3,000 first or the exponent first?
Neither. You actually do what's inside parentheses first, but what kind of a calculator are you using? Because most will do this all in one step.
I'm just using the one on my phone. My like actual like school calculator is like almost dead. It's charging.
Okay, well, that's going to be a problem because you definitely don't want to use your phone for this. Not because it's your phone, it's the wrong tool. It's just, really better to use the right one. So I dropped one in the chat there. I think we might have had you use that last time.
Yeah.
Um, it's really important that you be able to do this calculation. I already know how to do it. You're the student, you're the one that's going to have to do this in the classroom. So um, give this a try, please. Maybe using that tool.
Yeah.
It's also available as an app on your phone. I mean, I've got it on uh, the business phone that I use. So it's if you're more comfortable doing it that way, download it real quick. Called the Desmos calculator, I think.
Okay. I'll make sure to do that. All right, I got 3,695.27.
Very good. So B is almost the exact same calculation, except where there's a 2 that becomes 52. And it does change the result. I mean, not a lot, but it does change it enough that it really does matter here. So that ends up being 3,700.8081, like that.
All right.
All right, so that is 19. Let's see here, 26. All right, so we'll go to 22 next. Does that look right to you?
Yes.
The ones that we're skipping, does that mean you've already done them or they weren't assigned or what's going on?
Yeah, the ones like that I didn't send, I already did.
Excellent. Okay. All right. So we got an inequality here. 24 greater than or equal to 6x minus 2 times 3x minus 5 plus 2x. Always a good idea to distribute first. Send this negative 2 in. So that becomes, got the right pencil here, minus 6x plus 10.
Mm-hmm.
And then you combine like terms. So what do you see on the right side of the equation here that you can combine?
I see 6x and 2x and the other 6x.
Yeah, so if they all go away, it becomes just the 2x.
Mm-hmm.
All right, so we'll subtract 10 from both sides. 14 is greater than or equal to 2x. Divide by 2. X is less than or equal to 7. Sorry, I shouldn't have done that. It's 7 greater than or equal to x, and then you flip it.
Yeah. All right.
And so they do want to see it that way. Did the instructions say anything about uh, did the instructions say anything about graphing it or just writing it as an inequality? What do you say?
I think you just have to put it on the number line, but it doesn't really say a lot. It just says like solve and graph. Like
Okay,
that.
so you can, it depends how accurate you're going to be, but you're going to put a dot there, filled in at 7. The reason it's filled in is because of that line, and then it's to the left.
All right.
And make sure you shade to the left there.
Got it.
All right, so 23. Oh, there is a number line. I'm sorry, I didn't even see it when I did the snip. Okay, yeah, there's a number line.
Yeah.
All right, 23 here. So
Mhm.
we kind of did a problem like this the other day where you can move the fraction over. Like you could subtract 1/2 from both sides. Not sure I love that because the denominators aren't the same. You end up kind of having to manipulate dominators, denominators. I probably wouldn't say to do that. We then talked about this idea of least common multiple between the bottoms. Does that at all sound
No,
familiar to you?
yeah. I think I tried to do that, but like I kept messing it up somehow.
Okay, so the fastest way to get a common multiple is to multiply, and now we're going to multiply everything by 6. Okay, so um, like this is like 1/3 times x plus 1/2. So I don't remember exactly how we did this, but you're multiplying the top, the bottom, you're multiplying by 1. So it becomes 6x over 3. 6 times 1 is 6, so 6 over 2. 6 times 2 is 12 over 3.
And it doesn't apply to like the denominator, only the numerator when you distribute the 6.
Yes, I mean you are multiplying the bottom by 1, but nothing changes when you multiply by 1.
Yeah. All right.
All right, so this is so now we divide. This is 2x plus 3 greater than 4. What should happen is that you should only have whole numbers when you're done here.
All right. Wait, you're only supposed to get whole numbers?
Yes, like the idea of multiplying by this least common multiple is that you're eliminating the fractions. So if you get down to this line and you still have fractions, you've made a mistake. Either you chose the wrong number or you didn't multiply in right, but that's kind of your check. Now the answer could be a fraction, but this line is whole numbers.
Oh, all right. Okay.
Right?
For my answer, I got x is greater than 1/2.
That is correct. So on your number line, there's 1/2. It's an open circle, and it's everything to the right there.
All right. All right.
All right, so that takes care of 23. We're up to 26.
Mm-hmm.
All right, let me grab a snip of this. All right. All right, George Boros can pay his housekeeper $15 per week. Wow, that is not a very good rate. To do his laundry, or he can have the laundromat do it at a cost of 50 cents per pound for the first 10 pounds and 40 cents for each additional pound. Use an inequality to find the weight at which it is more economical to use the housekeeper than the laundromat. So the idea here is that there's two options. Option number one is that it's $15 is your cost. Is that clear where I got that from?
Yeah.
Okay. Option number two is, well, it's 50 cents or 0.5 for the first 10 pounds. Let's just say he does 10 pounds. That's $5 plus 40 cents for each additional pound over 10 pounds. So whenever we saw this in an earlier problem, whenever there's kind of this break point, you're always subtracting it from the variable.
Wait, why is it x minus 10 again?
The first 10 pounds are at a different rate, and then the next however many pounds are at the lower rate. So if
Oh,
you if you if you if you if let's just say it's 20 pounds, let's just say 20 pounds. Well, you're not paying the full 40 cents isn't for the full 20 pounds, it's only for the 10 pounds that are over the 20, over the 10. I'm trying to think of an example where you might see this in real life. Just it doesn't happen very often.
yeah.
So I know that this maybe isn't clear, but we'll try to just work through it anyway. So you're setting this. Um, we want to know when $15 is better than or lower than 5 plus 0.4 times x minus 10. So you can think of it as the housekeeper. Housekeeper is less than the laundromat.
Okay.
That's the language in there. When it says more economical, you were asking me about that before. That means cheaper.
All
It
right.
sounds better. If you have a friend who's cheap, they'd rather you say, "Oh, I'm just economical." They don't want to be called cheap.
Oh, yeah.
They probably are. So to solve this inequality, you're going to subtract 5 from both sides. 10 is less than 0.4 times x minus 10, like that. Is that okay?
Yeah.
And then you divide by 0.4. All right, so this is where you might need a calculator to get this result here, which is 25 less than x minus 10. Add 10 to both sides to get 35 less than x or x greater than 35. So what that means in the context of this problem is that if you have more than 35 pounds of laundry, which I don't even know how you even think about that, but I don't know what that means. I couldn't tell you like how much laundry that is. I mean, I never think of it that way. that's what it
Yeah,
is. It's better to use the housekeeper.
35 pounds of laundry. Ooh.
Yeah, I don't know.
All right.
All right. So I know we went through some of those really quickly, so we have some time left. Welcome to, do some more problems or look at some problems again. Or if you have other questions, we can
Um,
go through them. If
can can we just go back to 19, like the second part of it, like after semi-annually, like can you do weekly with me?
so, that is here.
Yeah.
Um, the only difference is n. N changes from 2 to 52. That's the only change.
Okay. All right.
So A is here, B is here. They're almost identical, except for that number there.
Okay. I got it now.
Anything else you'd like us to work on again, or similar examples of, or what would be best to help you here?
Honestly, like I think I get it all. Like I don't have any other problem or anything.
All right. Well, that is fine with me. If you do want to stop here, um, I'm just guessing maybe you're a little tired tonight. I am too.
Yeah, little.
Yeah. All right. Let's go ahead and stop the recording.